Hello, my name is Greg Clarkson, and I am the college algebra teacher, IT guy, and safety guy in our school. And I'm going to do a quick lesson with my remote students out of college algebra today. It's too bad you can't see what the room's set up like, and I've got a little camera here to show you what's going on in my room. And there's a lot of activities and stuff that I have posted on my boards and stuff. I have my learning intentions on the back wall. Pictures everywhere. This used to be my daughter's room, so she moved next door, and we have tiles that the kids painted and stuff, kind of related to our geometry stuff that we've been doing last year. I have a wall of fame you can see back there by the block that I like to put kids, recognize all kids and their math abilities and get their pictures up there. So we're in the process of doing that. I'm going to teach a lesson out of exponential and logarithm functions today, and I'm going to switch cameras. This is one of the things that I've been, we installed new cameras in our school this year, and if I can find my remote, I'm going to switch cameras and go to my board, and we're going to get right into the lesson. And this is what my kids will be saying as they are on the other end right there too also. So they might buzz in and if they have questions, if they need help with some things, but let me give a look at my camera from straight on. Okay, and you can see that. So we installed new cameras beginning of this year to help with the remote learning part. So really no excuses for our students right now to not be on, even if they're sick at home and they're not too sick, they can kind of watch in and not miss out on a lecture. Okay, so today, this is how I start the class. We're going to talk about what we talked about yesterday a little bit and kind of tie it in. We were just finishing up a test, and I asked anybody and everybody what was going on, if they had any questions, if they were comfortable with it. And everybody's giving me the thumbs up from the side of the computer I'm looking at. So we're going to look at inverse functions today, and I'd like everybody to remember when you took Algebra 2 last year from Ms. Woods, what we did about and talked about and where it was related to some outside things going on in the world right now. Visible light is very vital, important health of our ocean. We look at any body of water in particular, light penetrating through a body of water provides energy and fuel for microscopic plants and photoplankton. Okay, so what we're going to do is we're going to look at some formulas developed by scientists that show population growth, decay, things that are related to inverse functions, and how they're related to compound interest and everything that we do. A great example of this today would be interest rates for your home are at an all-time low and how they figure those. So we'll be able to do that down the line too. So there are some really useful real world situations for this. Okay, the first thing that they talk about in your book today or your ebook is identifying what a one-to-one function is. Okay, so you need to know the definition of that. And a one-to-one function basically is a function f is one-to-one if and only if a and b in the domain of f. If f is not equal to b, and then f of a is not equal to f of b, or equivalent if f of a is equal to f of b, then a equals b. Okay, so you go, well, that doesn't mean a lot to me. It will when I show you an example. It's really easy to see if a function is one-to-one by using ordered pairs. So if I give you the ordered pair, f equals 1, 4, 2, 3, and negative 2, 4, and they're going to ask you if that's one-to-one. Okay, so you go and you look at your definition, and our definition really states it right here is that you can't have any y values that are the same. Okay, so the y values are the same. You can see that all your x values are the same, but your y values are have a couple of them that are the same. Okay, so this by rule, and you can just do this, automatically says it doesn't have it. It's not one-to-one. Okay, so it's not one-to-one. And a better way of doing this is I have always encouraged you guys to graph that point and see what it looks like, and use the horizontal line test to see. So there it is right there. So when we do the horizontal line test, we have just proven that it's not one-to-one. Okay, so the best way to do it with an ordered pair is to look to see if all the ranges and domains, which are the x's and y's, are different. If they are, then it is one-to-one. Okay, if you do have a couple of x's, for instance, 1, 2, 1, 3, 1, 4, even though that your y's are different, your x's are the same, you can use the vertical line test there, and it doesn't have a one-to-one function. Okay, so the best way that I'm going to show you to do this is just by making up some graphs. Okay, and they want you to see if this is one-to-one or not. Okay, pretty easy. Do the horizontal line test, and you can see that it cuts it in about 3 places there, and therefore it's not. Okay, so it's easy to do that horizontal line test. Again, if I give you something like this, do a horizontal line test anywhere, only puts it once. So that is one-to-one. Okay, and you got to be careful when you use your hyperbolas. Okay, so another great example of that is they'll give you a hyperbola. Obviously, we know it's a u that's sideways. Okay, so if you look at that, you're going, wait, why is that not one-to-one? Well, because again, we use the vertical line test on this one, and the vertical line test shows it's not if the relation is not a function, it doesn't have a one-to-one function. Okay, so we can use the vertical and horizontal line test on it. Okay, so relatively easy. We're going to go back to a little bit of your geometry, if you remember that, and that they want you to use the definition to determine if it's one-to-one. Pretty easy stuff here. So I'm going to give you this linear equation. Okay, and all you have to do is remember from the definition, we just got to show that f of A equals f of B, and if that's true, then A equals B. So it's an if-then statement. So conditional. Okay, so pretty easy. All you have to do is substitution. Okay, so you're just going to substitute, set them equal to each other, and that's going to be relatively easy. So it just sets the functions equal to each other, put an A in there, put a B in there. That's all we did. Okay, and then let's show that it's true. Well, we're gonna subtract. We're gonna actually take the -3 to the other side and make it a 0. So we get 2A equals 2B, and you're going to divide by 2, and then A equals B. So we've just proven that is one-to-one. Okay, so they're going to ask you to do that on all those. I think one example is enough to do, but pretty easy. You should remember conditional statements, if, then, and then prove it. Okay, so it should be pretty easy for you to get done. Okay, I think the next part of determining if a expression has two functions are inverses of each other. Okay, you just got to remember your little deal about composite functions. Okay, so remember it's not a times, it's like a fog. Okay, and this. Okay, so composite functions. F composite of G equals X for all X is the domain of G, and G composite of F, X for all X in the domain of F. Okay, they have an inverse. So what is going to happen here, if you remember how to do these problems, is that I'm going to go up a little higher here so everybody can see it. Remember, that's F of G of X. That's what that means. And this means G of f of x. Okay, so relatively easy. So when they ask you to find whether they're inverses of each other, okay, you just have to go both ways to prove it. Okay, so if I'm going to give you an example, and I'm going to say that f of x equals 100 plus 12x, and g of x equals x minus 100 over 12. We want to find out if they're inverses. So when you multiply these out, your answer should be x. Okay, so, but you got to be careful when you plug it in. Okay, so you have to do it both ways. So let's find this function first. So it says take g of f, which is that, and put it in there. So I did this for this part of it. Now it says take this part, x minus 100 over 12, and then stick it into f. Well, if you remember, my f is right here. So now I'm just going to go in here and plug it into that 12. And I'm going to put everything in here, and you can see what happens for the whole thing. Okay. That cancels out with that. That cancels out with that. I'm left with an x. Okay. So far, so good. So I told you you should get an x when you multiply these out, but you got to go the other way to see if the other one is the inverse of the other one. Okay. So you're going to do the same thing, and you're going to take g f of x. Okay. So you're going to plug in g, and you're going to put in 100 plus 12 now, x. Okay, now you're going to take that and you're going to plug it everywhere there's an x right here. So I'm just going to do that. So it's 100 plus 12x minus 100 all over 12. And you can see I'm going to get the same thing again. Cancel, cancel. 12x divided by that is x. I've just proved that they are inverses of each other. Okay, so really not too hard. We've done this before in Algebra 2. I know Miss Woods has done that with you. Okay, you need to avoid one of the mistakes when it comes to the inverses. Do not confuse the inverse notation. This is the inverse notation, okay, with exponential notation. The notation f to the negative 1 does not mean 1 over f, okay, so it does not mean that, okay, so make sure you understand it does not mean that, okay. I mean, when we talk about you multiply, I want to find the inverse of 7, it's 1/7. No, see, we're talking about a different type of inverse here, okay? So make sure you keep that straight when you do these problems, okay? Next thing we're going to look at is how to determine procedure to find an equation that has an inverse, okay? So I'm going to give you an example, and it's a 5-step problem, okay, in order to determine it has a 1-to-1 and a inverse. Okay, so very easy. I'm going to give you the function I'm talking about first. So f of x equals 3x minus 1. Okay, so you look at it, the first rule says step, and I'll just do it in steps. Step 1 says replace, okay, replace your f of x, okay, replace your f of x with y. Okay, so I did that. So I replaced and put a y in there. Okay, relatively easy. Second step says interchange x's and y's. So step 2, interchange x's and y's. Okay, so I did that. So now you see I've got x equals 3y minus 1. Okay, now the easy step, solve for y. Okay, so I'm going to solve for y. So I'm going to take that across. Okay, so I took it across, added it, and now I'm going to divide by 3. Okay, there it is. Okay, so solve for y. I did that. Step 4, okay, says replace y. So I'm going to replace my y with my inverse sign. Okay, so I'm going to do that. So I've got it. And there is the inverse of 3x minus 1. Okay, so really not too hard. Okay, change your f of x to y, interchange your x's and y's, solve for y, replace y with the inverse of x. Okay, relatively easy. Okay, now they do get a little bit harder than that. Okay, we want to find an equation of an inverse function. They do get a little harder than that, especially when they start throwing multiple problems at you that are rational. Okay, so let's look at that. Let's look at this one. Now, do it the same way here. Okay, so again, I'm going to give you, if you write the whole process out, you're not going to miss the whole problem by following the steps I give you, because I want to see that you know the procedure to get to the answer part of this. That's important. Okay, so especially when we're dealing with exponential logs and logarithmic functions. Okay, so again, so I'm just going to replace this here. Okay, that was pretty easy. Interchanges the x's and the y's. Now, this becomes a little harder to deal with. Okay, we have to solve for y now. So in order to solve for y, we need to get the y's on the same side. Okay, so what I'm going to do is put that over 1. Most people don't. I do. I'm going to cross multiply, so I get x, y plus 3x equals 3 minus y. Okay, I need to get the y's on the same side, so I'm going to move this negative y over and this 3x over this way. So again, we're past the point of showing it on both sides. You guys are in college right now. Okay, doing college classes, we learned that. So I'm going to go ahead and bring that across. Make that a plus y there. Going to take that across. And I got this now happening. Now, I've got to solve for y, so I'm going to factor that y out. I got this little thing happening here. And now you can see I got y equals, when I divide by x plus 1, I have just found the inverse of that. Okay? So that's not terribly hard, but I lacked one step, and I didn't replace this, and I would have counted myself off a half a point for not following the rule. Okay, so there it is. I followed the rule. I got it. Now, I'm not going to get you on a test specifically with that. You get all the computation right, but there are rules in place. They like you to show the inverses of the inverse of this function. Okay, so it's not real hard to do. All right. Okay. There are a couple more practice problems that are just like that. In fact, the next two examples are the same. Okay. One thing they're going to ask you to do is, part of this is to remember how to go back chapter 1 and write things in interval notation. Okay, so let's just go back to this problem right here. So some of these answers are, they ask you to find the domain of the function in the inverse. So I'm going to go ahead and put the answer that I got for the inverse back on here. Okay, it was this. So if you wanted to find the domain of f of x, remember, look at the domain. We want to look at the denominator. Okay, what makes it 0? -3. So we know we can't use -3, so it comes in from negative infinity. Remember, anything from negative infinity to -3 works, and then everything outside that works. So that would be the domain of that. Okay, and then the domain for the inverse, not much different. Okay, we're going to come in from negative infinity to -1, union -1 to infinity. Okay, so they're really not hard to do. Okay, we've worked on this before, and they throw this in, this exercise in this section as a review to what we're going to see when we start finding domains and ranges again with logarithmic and exponential functions. Okay, So do you guys have any questions there? Looks like all my kids are okay, thumbs up. If you do have questions, again, you got my number. We can Google Meets at home. Individually, if you need to meet with me privately, let's do that. But again, thank you for watching my lecture. And this is how it really works in my class. Very traditional math. My room, it's just pretty small, but it's got a lot of stuff in it, colorful. Like the kids to enjoy what they see. A lot of math formulas up on the board. I think it helps them out. So again, thank you for tuning in, and I hope you enjoyed my lecture.